Alrighty. Okay, thank you very much for everyone showing up for this talk. Obviously, there's a lot of options, and I'm particularly actually very pleasantly surprised that I see a lot of familiar faces and a lot of speakers. So I think this is going to be an important talk for all of us, and hopefully a timely one, and perhaps a slightly overdue one. And honestly, I would actually request that you consider delivering this talk. So with that said, let me talk a little bit about the motivation of this talk. This talk is part informative and frankly part myth busting. I personally sort of got tired of the propaganda that Java EE somehow doesn't run on the cloud, right? The reality is absolutely the opposite. Java EE runs extremely well on the cloud. In fact, it's probably one of the best supported technologies on the cloud today. Yes, and that's kind of sad that somehow we are unable to get that narrative out there. Are we going to accomplish this in this one talk? Probably not, right? But at least we have to start somewhere as a Java EE community to begin changing that narrative and bring a little bit more balance to that narrative. Okay, so that's the motivation for the talk. I'll briefly introduce each of one of us. I have two really fantastic guys here working with me. They did most of the heavy lifting of the talk, I'll tell you right now. And I'm just so grateful for what these guys have done for the talk. With that said, I'll let Rodrigo and Ryan introduce themselves.
Hello, everybody. My name is Rodrigo Bortoloto. I'm a senior manager with CapTech Consulting. I currently serve as the capability lead for the cloud service offering and obviously being involved with Java for many years.
Yes, I'm Ryan Cuprak. I'm from Dassault Systems. I work in R&D on chemical formulation software. I run the Connecticut Java Users Group and have been co-author on a couple of books.
And my name is Reza. I'm a senior manager architect at CapTech Consulting. I've been involved in the Java EE ecosystem for a little while, and yeah, just here to share some stuff. This is a necessary evil slide. Obviously, CapTech is paying for both Rodrigo and my expenses to come here. So basically, we're proud to work for this company. It's really a great company. It's a nationwide full-service IT consulting company, wins a bunch of awards all the time. Have some fantastic people working for it, like Rodrigo here, unlike myself. Okay, so this is roughly our agenda. Firstly, we're going to be talking about Java EE on the cloud as a bird's eye view. Then we're going to dive into basically each variant of Java EE running on the cloud. So respectively, if you've been around the cloud ecosystem, none of these acronyms are probably surprises to you. So infrastructure on a service, Docker or containers as a service, PaaS, platform as a service, and also as a variant of that, basically running Java EE on bare JVM-based PaaS solutions, and finally Java EE as FaaS, or function as a service. Okay, moving forward. Java EE in reality has been running on the cloud forever. In fact, I have a number of customers that have been running Java EE on the cloud forever. In fact, it has been possible, and people have been doing it since the Java EE6 timeframe. So reality is this has been going on for at least a good 5 years. And it's really sad that we haven't gotten the narrative right yet. Especially, what happened, the cloud deployments that I've seen on Java EE so far, by and large, actually, a lot of it is IaaS-based deployments on AWS. Okay, and I think that's probably reality for pretty much most of the technologies out there. There are, in fact, incremental features that have been built into both Java EE7 and Java EE8 that benefit the cloud. Okay, and hopefully there's going to be a whole lot more coming up in the next releases of Java EE that specifically looks at the problem of what is it that you actually need in cloud applications running, Java applications running on various variants of the cloud. It's running Java EE on IaaS is super easy, right? In fact, running any technology on IaaS is super easy. So Java EE is definitely not an exception there at all. Most of the major IaaS vendors, it's very super easy to do that. Namely, the big players, two players really being Azure and AWS. Java EE plays also extremely well with Docker. Okay, this is another sort of FUD item, and I'd like to present a session on that too, and see how symbiotic the relationship actually is between Java EE and Docker. So all of the containers as a service providers that are based on Docker, because Java EE works well well with Docker, it works well with those CIS-based solutions as well. And in fact, there are many good PaaS options as well. I mean, really Java EE has the most amount of PaaS options, maybe with the exception of the bare metal JVM, right? So really a number of vendors that are focused on this. You know, some names are OpenShift, Oracle Cloud, BlueMix, Heroku, and Jelastic. And in fact, I probably haven't done justice to one, which thank you for reminding me, Pavlov, which is it's SAP. The SAP should have been in this list as well. SAP recently certified their cloud platform against Java EE 7. Okay. So to make it up, I'm going to write a blog entry about it. And believe it or not, you know, Java EE also can work extremely well in bare metal JVM-based platforms. I think this is a very interesting variant, and I'm very happy that that part is going to be covered by Ryan. I think he's going to do a really good justice to that, because that's been one of the FUD points, fear, uncertainty, doubt points, is that, okay, Java EE doesn't work in those environments, which is absolutely really not true, as you'll see. It is possible because we have a bunch of solutions out there that allow Java EE applications to run on Java SE environments. Some of those names are WildFly Swarm, Pyromicro, Cumulizzi, and WebSphere Liberty, and even that isn't actually a comprehensive list. Okay, so I won't spend too much time on this slide. Let me explain what this slide actually is. There's an application out there called Cargo Tracker. The intent of that application is to actually demonstrate solid design patterns, namely domain-driven design patterns in Java EE applications. It's a very handy application that I find to do all sorts of Java EE-based demos, because it's a non-trivial application. It's about 10,000 lines of code. It uses all kinds of Java EE APIs, JSF, JPA, EJB, JMS, JBatch, and the like. Okay, and we'll probably adding those lists as well. It was part of the especially official Java EE project on java.net. Since that's gone down, it's a part of the GitHub Java EE repositories, but it's honestly not in very good shape. So what we've done is we've hacked that thing, and we now have a mirror on a project that we call j3.github.io. Okay, and you'll find the former website that used to run on java.net running there temporarily. Hopefully we fix this problem and we make it part of the EE4J project instead of the J3E project. Okay, so Java EE on PaaS, on IaaS. What is IaaS? IaaS is simply your data center on somebody else's machine. Okay, so what you get is basically the bare, by and large, your bare hardware level machine provisioning that you, instead of ordering through your department and have your sysadmin install that for you, well, that's somebody else does that stuff, and you just click on some stuff, you know, on a web page, and it creates that bare metal machine for you. Okay, most likely using some virtualization software under the hood, rather than somebody physically buying a machine and sticking it in the rack. By far, this is the most popular path to the cloud. That's the reality. Most people that are using cloud are really using IaaS platforms, and of course, as you know, I think as we all know, the biggest players here are AWS and Azure. So Java EE, as I said, works extremely well on IaaS. Why wouldn't it? Right? It's just yet another server. It just happens to be hosted on somebody else's machine. So of course you can set up a Java EE environment and deploy your application there. Above and beyond, which we won't cover in too much detail, in addition to this, most of the big IaaS vendors actually have specific support for Java EE APIs. In particular, they provide images of Java EE application servers, pre-built images that you can much more easily deploy on their IaaS-based platform. So if you go onto Azure and you look at Azure image library, you'll see images for various Java EE application servers. Similarly, there's AMIs available on AWS that specifically target Java EE-based application servers. So actually, this blurs the line. We won't cover it in great detail, but this blurs the line between what is IaaS and what is PaaS. Actually, the line is blurring more and more. Right? It's literally a distinction between a few clicks as to how categorizing something as IaaS versus categorizing something as PaaS. Actually, I'm going to skip over the pros and cons for the interest of time because we have a ton of material to go through. So I'm going to not go over the pros and cons. I think for the most part we all understand this stuff. We'll make obviously the slides available to you. You can take a look at it. So that all said, let me turn it over to Rodrigo, who is going to present our first demo, which is running Java EE on bare metal IaaS platforms.
All right. And as Reza said, this is the link. So everything that we're covering is available on GitHub and SlideShare, so everybody can look into, with more details. So the first thing to go through, infrastructure as a service. We're starting with AWS and leveraging their EC2 service. So anyone here familiar with AWS EC2? A few hands, thank you. So this is basically their virtual machine option. As already said, you can go with many other cloud providers, right? So in this case, most cloud providers, they have some sort of marketplace that was kind of mentioned, right? So you can, identify one application server of your choice. And, I'll start with one very, interesting. So you can, search for one of your choice. You can have a configure image and you start and your setup is in place. Or you can create your own, right? So let's suppose you start your instance, your virtual machine, you make your configuration and then create your own image later on to reuse. And that could be very interesting. You could look at it as an artifact, right? Through your pipeline as you move from development all the way to production. You could very well have an artifact that becomes your AMI that's built in and packaged with several, pieces that will, go through your software lifecycle process. I'm picking up something with Ubuntu, nothing fancy here. We're choosing an instance type, which is pretty much how much memory and CPU we're gonna give to this virtual machine, right? Our next step is network, and these steps, they're common to any virtual machine type of service, right? So you define a network. You, obviously, in this case, we want to have public IP available, so we enable that as is. We're just taking the default configuration. We give some storage. So, and it's nice to see, contrast, and compare with all the cloud providers how they differentiate their UI or their APIs to make your life easier as a developer. Obviously, naming is something that it could be hard. But it's very important because in this case we're creating one specific virtual machine, but if you have hundreds of thousands of them running in your environments, your workloads, you need to identify and easily try to figure out what is doing what, right? So in this case I'm just giving some name, so I'm gonna call this my Java 1 EC2 instance demo. Then the very next step is to identify a firewall, which is in AWS terms is called a security group, right? So for that, we are deploying a Java application that's going to be running on port 8080. That application is running on top of a Glassfish, so we also want to enable the console admin on port 4848. So obviously we need to make those available, and for that reason, I already have one pre-configured, pre-set up security group here. We review things. We look at, there's a warning saying I'm going to pay for it, obviously. One thing that's interesting to note is all the cloud providers, they have a free tier, a free get started type of approach, all of them. So it's really good to take one use case that you may have and go and explore across different ones and identify what's the best option for you. And from here we launch that instance. You have to have a security, you need to have your PAM file so you can later on SSH. You say launch, and AWS will do something behind the scenes. Obviously, for interest of time, I already have one that's pre-configured. It's already up and running. And now that I have exposed that IP address, I can come in here and say, well, is there anything running? Oh, no. right? So let's see if I have something on port 4848. And apparently my internet connection is not helping me. That never happens, huh? So let's try again. All right. So how can you go into the cloud without an internet connection? Huh? But basically the idea is, and we'll see how this is going to shake with the next one.
Rodrigo, I think the suggestion was to type in HTTP in front.
Oh, the HTTP? Well, right. Let's see. Thank you. There we go. Thank you very much. So, this is, the admin console that's available. Now, if I change the port, and obviously you can do whatever you can do with any application server, right? There's nothing, that particular. And if I go with my port 8080, I should have a different message here, pointing that, saying that, my application server is up and running, and eventually my cargo tracker application. All right. But as it loads, and for interest of time, I think the message here is, behind the scenes, you didn't see that I had to set up Java, you didn't see that I had to set up Glassfish myself. So the point being is, there are no changes on my application, it was just a WAR file. You need to think about infrastructure, right? You need to think about network, configuration, firewall, so there are some takes there. And you need to play a little bit of admin role in this scenario, so regardless of the cloud provider you pick.
Okay, great. So the next variant that we're going to talk about is essentially using Java EE with Docker or container as a service platforms. So what has happened, as Rodrigo mentioned and I mentioned as well, Amazon has this concept of AMIs, okay, Amazon images. Similarly, Azure has a concept of images, right? The reality is these are proprietary images specific to those platforms. So if you want an image, you've got to create an image and upload to their marketplace somehow, and et cetera, et cetera. So the reality is all that is kind of unnecessary because Docker is becoming such a commodity, right? So instead of relying on their own proprietary AMI systems, what the IaaS providers and some of the PaaS providers are doing is simply saying, hey, we support Docker, right? So whatever your image may be, get your image from Docker Hub or create your own, publish your own image into Docker Hub and use that to spin up a server instance, and in fact, multiple server instances in some cases. So most of these solutions that containers as a service solutions aren't just a matter of spinning up individual instances with Docker images, but they actually have orchestration built into that as well, with all of the orchestration frameworks that are out there to support Docker. Principally, actually, Kubernetes is the most predominant one. So most of the cloud providers are supporting Kubernetes, and hence you can essentially spin up and down, your cluster and create a cluster, and not just a simple instance in a relatively automated fashion. Right, so so that's what's called, this new model called containers as a service, and actually it's fairly prevalent already. So as I mentioned before, Java EE is actually a very good fit for the Docker model. It works extremely well. There's several reasons for that. So this didn't used to be the case. So some of the FUD items around Java EE and Docker are basically outdated. Right, so this was the criticism that is out there that you'll read on the internet. Basically, what they're trying to tell you is a Docker image is monolithic, right? So you want that Docker image to be as small as possible, so that monolithic Docker image doesn't get too big and it doesn't get too difficult to deploy and the like. Well, guess what? The Docker guys have figured this out. Figure out a problem, because this is not a solution. This is not a problem specific to Java EE. Well, guess what? If you have a database server or a web server, that has the same problem, right? And they produce large images. So the solution in Docker that's been out for 1.5 years now is something called Docker layering. Okay, what that means is that you don't deploy your entire Docker image every time. What you deploy is actually what changed in my image, right? So what this means is, you can follow essentially the natural model that Java EE application servers has in terms of separation of concerns, right? So your infrastructure layer is your app server, whereas your var is only the delta that you apply. That's the only thing that's changing from one Docker deployment to the other, right? So the initial Docker deployment, yes, that's going to be large because it'll contain the app server and your var. But guess what? Subsequent deployments of your Java EE application server is going to be much smaller compared to any other alternatives because your incremental bit is very clean, namely just the var file. Okay. In comparison, let's say you've done some effort to create a fat jar solution. Well, guess what? Because that fat jar solution doesn't have that clear demarcation between the deployment unit and the infrastructure, you'll actually be deploying a heavier weight Docker image every time you deploy that. Okay, and the same thing happens, again with Docker clustering and Docker caching. All of this, because of those capabilities, mesh extremely well with Java EE applications. Okay, so then so what does that mean? So what does this means is, now we should then evaluate, well, what if you look at Docker Hub or if you look at the Docker ecosystem, how well does that support Java EE? And it turns out it supports Java EE extremely well. Right, so there's literally Docker images available of every single Java EE platform out there. Right, there isn't one that doesn't have a pre-built Docker image available that you can just use and run with and keep going with. Okay, so with that in mind, I am going to turn it over again to Rodrigo. He's going to he's going to show you how to deploy Dockerized Java EE images onto a cloud platform.
All right, and this is the result that we were expecting from the previous deployment, right? So, as Reza said, the first step is we need a Docker file, right? So we need to get the war file that initially we, had in our infrastructure, deployed to an application server. Now we have, in this case, a Docker file. We're going, in using Payara, which, by the way, announced today they are the first or one of the first to support Java EE 8. So that's really, really great. And you see 3 lines of code. We have Payara, we have deployment of our war file, and we then start our domain. This is available in GitHub. There is a reference for that. And after that, you can push your Docker image, right? You create a Docker image, you Docker build, Docker tag, Docker push. Right, you need to build it, it constructs the image, you need to tag, so you associate your Docker image with some destination, with some Docker registry, and then you push that to some Docker registry. In this case, we have that available. We're going to use, once again, AWS. We're exploring ECS in this case. This is their EC2 container service for the same purpose as Kubernetes, or one of the similar. It does offer a container registry, so this gets started, kind of walks you through in a very nice and easy way to learn and understand how you can set up and create your Docker registry. So I can come in here and say, I'm going to create my cargo tracker repo, do an next step, and it gives you all the information that's basically a copy and paste. And what you're going to do with this is you build your Docker image, again, locally, you tag, you push, that becomes available within the AWS ecosystem, or you can expose somewhere else if you want that, if you want so. In this case, I'm not going to run those steps, again, for the interest of time, but I have done, obviously, that before, and I have already my repository here. I'm going to copy my repository URL, and I'm follow with that for my next step. So once I have my repository, the other thing that I need to think about in AWS terms, but in general, that this knowledge gets transferable anywhere else, we need a task definition. And what does that mean? Every time you run a container, you need to specify, or may want to specify, what ports you are exposing. When you do a Docker run, you expose ports, you mount volumes, you give environment variables. So there are a set of configurations that you provide along with that Docker run that you translate that into a task definition, right? So in this case, I'm going to keep, since I'm doing port 88, I'll keep that port 88 here. Obviously, for more complex deployments, you want to let the container orchestrator to identify and dynamically assign a port to you. You don't want to tie yourself to a single port that will bring host, virtual machine constraints, so that opens up a lot of questions. The next step is a service. So once we have a Docker container available in a registry, we define what we need for that to run. Now we have a service that will say, you know, keep this guy running. I need one Docker run or one container running at all times, or 10 or 100. So this in our case is our cargo tracker service. I'll say that we just need one over here. I'm not going to put any load balancers or anything more complex at this time. And then with that, my service needs to run in a cluster, right? And that cluster is not a traditional, you know, WebLogic cluster or application server cluster, but it's more of a, think of a higher level unit where you can have multiple services within that cluster, and that will orchestrate and coordinate all the container placement and all of that. So in this case, here's my cargo tracker cluster. We can specify the size of the virtual machines that will be assigned to that cluster. So once you create your container orchestrator, you need to give it some computing capacity so it can deploy containers and run and whatnot. So we're giving here some CPU memory combination, AWS terms, for the instance types. We say how many of those we will assign. Again, I'll give my key pair over here as everybody would. We review next steps, and then we would be able to be in a position to just run it. Once we run this, it's very interesting because this graphical user interface, and just like everything else AWS, is exposed through APIs, CLIs, SDKs, and so you can automate everything, which you should, right? If you're deploying something in the cloud, that should be 100% automated. And they have something that's called CloudFormation, and behind the scenes, CloudFormation is managing and creating all the orchestration of those services for you. I have one cluster here already set up. I have my cargo tracker service. You can see that I have given one virtual machine associated to it. And since I told it to run one service, I can come in here and say that there is one Docker run, which AWS calls a task. And from that task, I can get all of its details, and eventually I get to the application. So let's see if this time I'm going to have more luck. So that works perfect, right? So I have packaged with PyR as you saw before. And if I do cargo tracker, here's my application once again, available and easy to run, easy to use, as well as it would be the console admin.
Okay, the next up is platform as a service. So as I said, the distinction between PaaS with images and Docker and really PaaS, IaaS and PaaS at this point is that that image is built in as very closely into a UI, right? So you don't have to do anything else. It just natively supports whatever application server that is. And in many cases, actually, the application server itself is implicit. So whenever you're using that PaaS solution, it's just implied that you're using that particular application server, and that cuts down some of the boilerplate and some of the additional steps that you would need if you weren't using a PaaS solution. So basically what happens here is that your deployment unit really becomes just point and click, set up your server, and you just deploy your WAR file, and that's your basically your deployment unit. Typically it'll come with some kind of console access that you can manage your application with. And of course, again, yet again, a lot of Java EE PaaS solutions available, OpenShift, Oracle Cloud, BlueMix, Jelastic, and ASAP. Also, again, I'm going to skip over the pros and cons. I think it's a little maybe besides the point, so that we can get to the demo, and Rodrigo can kind of dig into a bit more of the details here.
All right, so shifting gears now, and we're going with Jelastic. Anyone here familiar with Jelastic? Great. Several hands up. I think Jelastic, it's crazy, but I think it's fantastic. Right, it's so easy to set up something. I've never heard before, to be honest. I've never used it before, and I think that's what I want from a cloud provider. That's what I want from kind of a platform, something that I can look and easily get started. Right, so they have the concept of you can import environments, you can export environments. They also have a marketplace where you can leverage pre-configured environments. In this case, we're going to go with a new environment, and just like with PyR, Jelastic is also supporting JE8, so that's phenomenal. What I want to show here is they have support obviously for Java and PHP if someone is interested in PHP. They have Docker and other stuff. But look at this UI, right? What we're seeing here is we can define and we can use a good selection of application servers on the Java ecosystem. They have Glassfish, they have JBoss, Payara, and many others, right? So this is really good. It's not something that you find in every single cloud provider. But with that said, here I'm going to pick up Payara. I want to get the latest version of Payara. It's loading. As you can see here, I'm getting JDK 8. It's the latest version of Payara. If it brings you here on this middle box, can you see that well? Let me give you more. Right, so if you look at this middle box here, it already out of the box gives you scalability, so you can have vertical scalability, which is basically how much memory and CPU you're going to allocate from the beginning, right? So in this case, I'm saying I'll give you 3 gig of memory with this much CPU, and you can grow up to a certain level. So if your application is under load, your computing capacity can increase with you. And at the same time, down below, it's also providing horizontal scalability. So again, if you have one node or if you need multiple nodes, it's just a matter of defining what do you want, right? The interesting part here is if you note, it also, once I add more than one node, it created for me that that extra layer for load balancer, adding an Nginx load balancer. So that's very handy and very helpful, especially for those that already have workloads running on premises. There's a high chance you're doing this with Nginx or a similar kind of proxy load balancer solution. So it's very good. They also have some interesting, that they offer you the cost as well, which I think it's valuable and it's useful out of the box. They have some variables, as I mentioned, on the part of the exporting the environment. So there is a pre-configured environment installation setup process here that will automatically put your Payara or Glassfish in cluster mode. So before, on the other 2 options we were looking at, we would have to do that heavy lifting ourselves. Right, so this is, it's very good. And you would have an environment name, you can give that environment name, set up a DNS and whatnot. One other thing, you can connect your application through Maven. In this case, I have the cargo tracker WAR file here. I can click on it. I have a couple of environments pre-set up, and I can define, it understands it's a WAR app, it understands it can be deployed to that specific environment. So again, it's the same operation as you would do going to a console admin saying deploy WAR file. So that also becomes very, very handy. The piece that I want to show you is that I mentioned I have one pre-configured instance over here. Let's go to it, which is the one that I mentioned about the auto clustering. Oops. Let me get this user and password. And I just kind of want to show that because I think, again, it does add value as we are going through this. So you're looking at the Payara. As you see, there is a cluster here set up, and I didn't have to do anything. And then down the road, you can deploy your application either through the web console, or you can just come in here and select your WAR and deploy. In addition to that, it also gives some metrics. This is the topology, but it does give some really nice metrics that you can start analyzing what's happening behind the scenes. It opens you something that's interesting. It gives you access to some of the files from a folder structure perspective. So again, overall, with this, with the previous approach, when we did Docker, we had to create a Docker file. We had to learn a little bit about a container orchestrator and whatnot. And in this case, we didn't have to change anything in our application. It remains to be a WAR file, right? And the infrastructure knowledge was very minimal. So I think that adds a lot of value for those that want to explore and go take that path to the cloud.
Okay, moving forward. So although most cloud providers out there, when they're talking about Java support, they have some way of installing an application server, either through a Docker image or a native image that they build, or it's built into the platform, like in Jelastic's case. However, there are a small number of cloud providers out there that don't provide that flexibility. The only thing they support is really either Tomcat or Jetty, or here you go, here's your JDK environment, and that's all you get, right? And then you have to build the rest of your applications based off of that. Right, so there aren't a whole lot of these. Really, the only ones that have this sort of restrictive environment is Heroku and GAE. Well, obviously, in this situation, all of the other solutions that we talked about isn't going to work because they all entail some kind of installation or some kind of pre-configuration of an application server. That's not going to be possible in this case. However, what you can do here is actually not depend on that, because now you have all of these Java EE, nice Java EE fat jar solutions that you can just create a jar as opposed to a WAR file and deploy that on top of a bare metal JVM. Okay, so I'm going to do a little bit different in the interest of time here, and this is going to be a little bit of a surprise for Ryan. The only reason I'm doing this to him is because I know he can handle it. So I'm going to actually just talk about our final deck here, which is our resources, okay? And then I'm going to actually hand it over to Ryan for majority of the rest of this time that we have, which is we have about 10 more minutes left. So what we've done here is try to give you a really good starting point for getting started on the cloud with Java EE applications. Your best resource actually is the GitHub repository that Rodrigo showed. He actually has specific instructions on each of the cloud platforms and some that we didn't show, step-by-step instructions on how to get started on those. In addition to that, there's some that obviously we didn't have time to cover, right? So the nice thing about it is I did actually do some research and try to find point references on those particular cloud environments of how do you set up Java EE in those particular environments, similar to what perhaps what Rodrigo would have written up in his GitHub repository. So those are some additional resources in addition to what you have with Rodrigo's GitHub repository. Final word that I'm going to say, if I don't get to say anything else because of time, is that basically our aim here is to get you started on running Java EE applications on the cloud as quickly as possible, and give you can use all of the resources that we already went and created so many man hours to create. So you can utilize that, and of course, for those of you who are speakers, please consider delivering this talk. We made the talk such that you can just take and run and deliver this talk. So with that, I am going to hand it over to Ryan probably for the rest of this talk. And I will tell you, this is what he has is probably worth a talk on its own, right? So really not doing Ryan justice here.
Thanks. So now that we got that out of the way, I guess I'm clear till talk to 7, right? Actually, this was so simple that I had to make this longer because it's so quick to actually deploy the application. This is actually easier than I thought it would be. Prior to working on this presentation, I hadn't actually used Heroku previously, thinking that I'd been at conferences where it was primarily Ruby developers that were using it, so I thought it was a Ruby platform. But that's not the case. It's actually a very good Java platform. It comes with Java 8 installed. It's a little bit different than the stuff that we've looked at before, in that in order to push your code up there, you actually use Git. So you'll actually use Git to push the code to it, or you can have it tied into your Git repository so that every time you push code, it pulls from you, it does a sync and pulls down for you. It does support add-ons, and it's got a number of add-ons. It has like database add-ons pre-configured so that you can get up and running quickly. It has RabbitMQ, which I won't be using for this presentation. It does support process scaling. Everything runs in isolation. It's got a very nice logging infrastructure so that on the command line on your computer you can get the logging back. So it's very developer-centric in my opinion. It does have a free tier for experimentation, and then a hobby level that's one step up, which basically doesn't sleep, but it doesn't put it to sleep after 30 minutes. It starts with around 512 megs of RAM allocated to the app that your Java process gets allocated. So depending upon your application that you're deploying, you may need to actually move to the paid tier if it's a larger Java EE application or parts thereof. The previous part of this presentation, we focused on Payara, the full server. In this part of the presentation, I'm actually going to look at Payara Micro because we're only able to basically deploy a jar file to the server. We can't actually copy up a full server, although I think there are ways of getting around that, where you could check Glassfish into your Git repository and then pull it down that way. But I wouldn't recommend that. With Payara, it's Payara, or you could have done this. I actually had a separate demo that I was working on with Swarm Micro, so you could do it with either of these two. Payara is nice in that it was easy to get up and running within a couple of minutes. It implements if you're not familiar with it, implements the Eclipse micro profile, about 70 megs in size, and you get all of the services that I've listed down there by default. Their documentation is a little off right now in that they say EJB Lite, and EJB Lite means that you don't get message-driven beans. They actually do support message-driven beans, so hopefully they'll get their documentation updated soon with that. Since this was so simple, I had to make it a little bit harder, so I decided to pull in AWS. So with Payara Micro, you don't get OpenMQ by default, so you don't have a JMS provider. Heroku provides RabbitMQ as an add-on. However, there is no RAR file resource adapter available to plug into Glassfish or into any other app container. So in order to use message-driven beans, I needed to find another solution. So what I did was I used Payara has a proof of concept RAR adapter for Amazon SQS, the Amazon's queuing system, which meant that all I had to do was create the queues up on Amazon and then add them to my code. The Cargo Tracker application, thus I'll show the modifications that I made to the Cargo Tracker application. Thus far, all the demos so far, there have been no changes to the actual application. This time I actually had to make changes. One, to get the Cargo Tracker off of OpenMQ because it had hard-coded settings in there to begin with. So that was the primary changes that I made to it. And then the second one was to adjust it for using the Payara SQS plugin, RAR file. So that's basically that. So starting off, this was the initial OpenMQ MDB code. So I'm basically showing, so this is the starting code where we have our message-driven, we have our destination, the lookups, everything for OpenMQ. And when I change it over to using the code that the RAR, you have to change the code a little, I have to change the message-driven bean a little bit to make it work with the Payara SQS adapter. So some of the changes, I had to change it to an Amazon SQS listener. If you implement message listener, it actually tries to fire up, it actually tries to look up OpenMQ, which is not actually installed and errors out. It took me a while to figure out that that's why the application wasn't actually running. Because I was like, well, I was checking, I thought I had left a file around somewhere. I've removed all of the access keys, obviously, for the presentation. Right now, they don't have any, there's not an easier way of getting them in there. And then you annotate a receive message with on SQS message to receive the message. And then in the web.xml, remove all of the references for OpenMQ, which is just a delete, don't have to add anything in there. And then so the application deploys on the root, remove Cargo Tracker, so that you can just go to when you open the application, you don't have to open another site to then navigate to the Cargo Tracker application / Cargo Tracker. So it just makes it open on the root of the application. The other set of changes, Cargo Tracker has one class that basically dispatches events to OpenMQ, so that class required a little bit of a few changes. So this was the Java EE 7 code for connecting up with the queues. This was the changed code, this was the code for sending a message, where it's using the JMS context to send it, all standard. So this is the revamped code to use SQS. So as you can see, I add the connection factory up at the top, do the resource lookup on the SQS connection factory, and configure it in the constructor, and then the method for sending the message. Right now, they only support sending text messages, so I had to adjust some of the code in there that was sending objects to actually convert them to text. The deployment steps are fairly simple. You install the Heroku SDK locally on your computer, and this gives you a command line to execute commands. So the first one you execute is actually Heroku login, which then sets up a session. It's like doing the AWS login for the first time on your local machine, so you don't have to log in for all the subsequent commands. To create an application, you do Heroku create. If you don't provide a name, it makes up something random for you. You add a proc file with a command line to invoke your application. You then commit your changes locally to Git, and you do a git push to Heroku. So you just say git push to Heroku. The command line has already set everything up. And your code actually, what Heroku does at this point was it pulls from your Git, it takes the code that you push to it, and it does a Maven build over there. So it actually builds the code. It's not, you're not deploying built code, you're deploying the source code file, and then it builds it and runs it, right? So it's clean. You don't have to worry about something, you know, as cached output on your local machine ending up there. So after you've done that, you can scale it up. So I start up one Dynamo to get going, and then you do Heroku open to open the application. And then finally, if you want to see the logs, you do logs/tail. Now, I mentioned the proc file. The proc file is the magic that makes this all work. So at the beginning, I have the web colon that tells it that it's a web application. So it's actually going to make sure that I bind to the port. So if my app starts up and it doesn't bind to the web port that's expected, then it will say that the startup failed and it will kill it. So this is the command line for starting up Pyra Micro. I do java-jar, Pyra Micro, that's the Pyra, that's the entire Glassfish application server in one jar file. I do -- port, and the $port is the environment variable, that the port that Heroku wants it to start up on. It's not going to be port 80, and it's not going to be port 8080. It's going to be some port that they made up, right? And they're going to be looking to make sure that you bound and are serving up content on that. I deploy the RAR file, and then I deploy the tracker war. And as you can see, I've got the target/cargo-tracker.war. So I'm pulling the code that it built. So I pushed it, it built the code. The war file is in the output, and now I run it. And that's basically the demo. We're out of time. But that's, you know, you can have your application pushed and running up there in no time at all. If you go through their administrative console, you can set up SSL certificates. You can easily add on stuff onto it. So it's really easy. I had to make it more complicated, make it longer.
Do you want to spin up the application?
Sure.
Yeah.
Nothing like living dangerously. And the one thing I will say, so, okay. Oh, I need to make that a little bigger. I never do this. Okay. So the first thing I have to do is do a Heroku push. And what you're going to see is the output from the server. Oh, everything's up to date. There's nothing to push. So it's actually already running. If I was creating a new app, I would do Heroku. Create. Heroku create. It's going to create. So this is creating another app up on Heroku, which I'm going to then push to. Okay, so another app is done. The app name is actually still, they created this random name, Stillridge. I can now push my local, because my code is in Git locally, so I'm pushing, everything's up to date. And I can do, it's actually already running, so you don't get to see it run. Application should be running.
Okay, well, that's up and running. Basically, in summary, next time somebody says Java EE doesn't work on the cloud, please call them out on it. Java EE works on the cloud extremely well. Honestly, there's lots of more options than just about anything else. And please, on your way out, leave us some good feedback. You know, lots of hours and lots of personal sacrifices to make this demo happen. So please help us out by giving some feedback.
And to get the logs when something doesn't work right, you do Heroku logs --tail, or the number, it's just the standard tail thing. And there we can see all of our logs. So I was able to, you're pulling back the logs for what's actually executing up on the server. So you can actually see the app is deploying right now. We're still deploying. So it's actually instantiating the Derby database. There we go. It's actually running now. There we go.
Cargo tracker.
So that's running, and it's talking to if we start executing actions, the queuing stuff will be handled by Amazon.
Okay, thank you very much. I appreciate it. Thanks for patience. Hopefully this was useful.
Thank you.